In this video, I want to show a few ways of using JavaScript to create and modify content dynamically in the browser. We're going to take a look at two mini projects: an articles list showing how to automate content creation, or simply how to add stuff to the document that isn't there initially right after the website is loaded, and a simple to-do app focusing on the problem of content modification during the application runtime, like changing text, showing, hiding and removing elements, etc. By the end, hopefully, you'll understand why front-end frameworks and libraries handling templates and state management are so popular. Keep in mind, this is not a tutorial of any of the technologies featured in the video. I rather aim at building some intuition around those topics. All the code presented throughout the video is available on GitHub, link in the description. Imagine you have an articles list or any other kind of a list like products, users or a to-do list. Assume you can only use HTML and CSS, so your code contains a lot of repetition as we want every element in the list to look the same. Now if we want to add a new element, we effectively have to duplicate the HTML tags of some existing article element and then replace text and attributes within the duplicated HTML with the new article's data, like the title, path to the thumbnail image or the description. The obvious problem with this approach is, if now we want to make a change that should be reflected in every element of the list, we have to manually edit all of them. If you want to remove article tags list, you have to edit all the HTML. If you need to update heading tag, you have to do that for all the articles. If someone tells you to change the class name of the article element, you have to repeat that as many times as many articles are in the list. To get rid of the duplication, we want to separate the data itself from the presentation of that data. In one place, we want to have a list of entities representing things like the article title, publish date, or the path to the thumbnail image. In this case, and throughout this video, the data is hard-coded into the script for simplicity. In real projects, most often the data is loaded from an external source like a server with API endpoints. In another place, we want to somehow describe how the data should be presented before our eyes. We want something like a blueprint, a template, or more generally speaking, certain functionality to convert that bare data into a nicely looking content on the website. That functionality will be contained in a JavaScript code that will dynamically create all the HTML tags and insert article data into proper places within those tags, like the article content into the paragraph tag or the path to the thumbnail image into the source attribute of the image tag. Having the raw data in one place and the functionality in separate script, now on the HTML side we can safely remove the whole contents of the list. With this setup, now if you want to add a new article, you just add an object to the array. If you want to update the article title, you don't need to search for the proper place in the HTML anymore. You simply update the object in the array. In the same way, if you want to remove an article, you remove the object in the array instead of removing a bunch of HTML tags. So we've automated generation of our list, but the JavaScript code is not without flaws. The code that inserts all the HTML elements onto our page is verbose and quite hard to read. We have to use a bunch of functions like create element and append child. It's easy to make a simple mistake like mistyping an element name or appending an element to a wrong parent. The solution to this problem are template tags. In the previous step, we removed the whole HTML of article elements, and as it turns out, we'll need it once again, but this time only the HTML of a single article, which will serve as a blueprint for all our article elements. I suggest replacing all the text and attribute values within the template, the ones that are about to be assigned with an actual article data, with some placeholder descriptions to make things more clear. Notice that we use additional template to generate article tag element. In practice, templates may contain multiple subtemplates that in turn contain even more nested templates and so on. This particular one is very short, so splitting it may not have been necessary, but it will come handy if we want to extend our article tag component with some additional HTML structure, so you can say that this template is future-proof. Now on the JavaScript side, we need to reference the article template just once and use it for every article data object in the array. Notice that previously we had to generate all the HTML tags by ourselves, but now the template provides a new copy of the HTML for every article, and the only thing left for us is to replace placeholder text and values mentioned earlier with the corresponding article data. So templates greatly improve readability of our code thanks to using just the right amount of HTML, but we still need to write some code to replace the placeholder data inside them. We have to use the query selector function to reference proper elements, where once again it's quite easy to complicate things, this time by mistyping the selector value. Also, if at some point in the future we change a class name of some element that is referenced by the script, we have to remember to reflect that change in the selector function by updating the string value. Fortunately, there is a way to improve things. Handlebars.js library is very similar in its functionality to the template tag, but it also provides a variable interpolation and helpers like if-else conditions and each loops. An important thing to note is that Handlebars is an external library that we need to explicitly import into our project. So now our code is not a so-called vanilla JavaScript anymore. There's at least a few other templating solutions similar to Handlebars, but I've chosen it for this step mostly because I'd spent a considerable amount of time working with it a few years back until I switched to better solutions. To migrate our code from HTML templates to Handlebars, we don't need to do much. Just replace the wrapping template tag with a script tag with a distinct type attribute. The HTML inside stays mostly the same except the variable interpolation and the each helper that iterates over the article tags. On the JavaScript side, the only thing we need to do is to reference the article template, compile it and iterate over the articles, passing corresponding data to the template function. In doing so, our script has become much shorter and easier to maintain. In this step, I also decided to split the CSS into a few files that are loaded separately. This is a small introduction to a more modular code organization for the UI components like the article and tag elements, but you'll need to wait for the second project to fully experience the efficiency of modular architecture. Now we'll use something called template literals to store HTML directly inside JavaScript strings. In the previous app, the CSS was split into separate files representing components like article block or tag block. This time we take this one step further and we also split the templates. In the result, index.html becomes very short as it now contains only the wrapper element for all the HTML that is supposed to be generated by JavaScript. Component files contain the minimal amount of code compared to previous examples. It would be hard to make it even shorter and easier to read than that. In the main script, we just assign the resulting HTML string to the mentioned wrapper element and we're ready. We use plain old JavaScript to interpolate variables, iterate over loops, and display subtemplates instead of using custom syntax like in the case of Handlebars. On the other hand, as the HTML is being stored in a string, we have no syntax highlighting, no tags autocompletion, and no checking for syntax errors, unless our editor supports such combination, for example through an external plugin. Notice that we don't load all the JavaScript files using separate script tags. We request only the main script as a module, and the script in turn imports other scripts it's dependent on, and so on down the hierarchy of scripts. It may not seem like a big deal, but it makes it significantly easier to write a modular code, especially in case of more complex apps. In my opinion, template literals are the way to go if we're forced not to use any external libraries in the app like that, or we want to keep the JavaScript code vanilla as much as possible. The last variation of the articles list project focuses on the React library. In this step, we could have probably put any other of the most popular front-end frameworks or libraries, like Angular or Vue, but I've personally spent the most time and I've had the most positive experience with React. Note that I've been using my own opinionated web app stack consisting of TypeScript as a statically typed alternative to JavaScript, React for templates, MobX for state management, and styled components for CSS, all bundled with Webpack. We'll discuss this combination at the end. For now, let's make one step at a time. React components are neatly contained in separate files that mix JavaScript and HTML-inspired syntax called JSX. Much like in the template literals approach, we use plain old JavaScript to interpolate variables and iterate over loops, instead of using custom syntax like in the case of Handlebars. In this case though, the HTML is not merely a string, but a construct with a clearly defined syntax that provides us with an error information the moment we make a typo, or use any kind of an invalid syntax. Also notice that React hides any logic related to element creation, referencing elements, etc. We just write render functions and compose the components as if they were plain HTML tags. All the examples so far have been running the exact JavaScript and CSS files we have in the project folder, but now it's time for something different. JSX syntax popularized by React is not supported by the browsers, so we need to somehow transform the files containing JSX to a browser-readable plain JavaScript code. There are various tools available out there, but we'll specifically use Babel to compile the code and Webpack to bundle it into a single script. Having Webpack set, I thought it would also be beneficial to convert CSS files into the scss format, which presents a few great improvements over CSS like nested selectors, variables, and mixins, but just as the JSX is not supported natively by the browsers. The positive side effect of Webpack taking care of styles is that we don't need to include the paths to the CSS files in the head section of the HTML document anymore, as we'll be importing them directly in the corresponding JavaScript component files instead, thanks to the Webpack magic. Because we need the NPM or Node Package Manager ecosystem to install Babel and Webpack, we can use it to install React as well, so we won't need to request the React library from the CDN like in the case of Handlebars. React, being processed by Webpack, will be included into the bundle script with the rest of our code. You may feel like using React with all this NPM, Webpack and Babel setup is an overkill. We need to create more files and write more code to get to the same point as in the case of any of the previous examples. That's why we'll move in a moment to the next project, which will provide us with plenty of use for React, thus justifying all this preliminary work. Before we step into the next project though, you may wonder whether the articles list example with its seemingly limited practicality is purely academic, or if there are some real-world applications of this dynamic content creation. I've shown in my previous video that basic knowledge of scripting can enable you to create small tools in the form of single-file websites that can dynamically create a gallery of sorts, a large data table, or something like an image generator. This is the end of the first part of this presentation. In the second part, we'll move to a more complex app where we introduce state management and we'll talk about React in more detail.